All right, here is our video about 11.4 with hyperbolas. I would recommend that you try the Desmos activity because I think a lot of students told me that they found it helpful. If you didn't find the ellipse one helpful, then that's up to you. I'm not going to say that you have to do it. So hyperbolas are a quadratic relation when the x squared and y squared terms have opposite signs. So one is positive, one is negative. And a hyperbola ends up looking like two parabolas going in opposite directions. It's not really two parabolas, but it looks that way. The official definition is a set of fixed points such that the difference between the distances from two fixed points is a given length, so some given constant. So go ahead, tap the link, do the Desmos. You can pause this, come back to it later if you want to. Okay, so what is the general equation of a hyperbola? Well, it's got two different forms depending on whether you have a horizontal or a vertical. So one thing that I want you to think about is the foci are really these 2 points. And that definition really meant that if I take this length and that length, and I subtract the big one minus the small one, I would get the same value no matter what place I chose on my hyperbola. So if I chose some point over here and I find the big length minus the small length, I end up getting the same value for each and every one of those. That's what that definition is really talking about. Okay, so the foci I've gone ahead and highlighted there. The vertices are going to be these 2 points right here. Whoop. Doesn't seem like it wants to graph them. Okay, and then the asymptotes are those dotted lines. So this first one is a horizontal, and the equation would be something like x squared over a squared minus y squared over b squared equals 1, always equals 1. And then this one is a vertical, it would be y squared over a squared minus x squared over b squared equals 1. This is different than an ellipse because a squared is always with the positive term. In an ellipse, a was always the larger number. In a hyperbola, that doesn't have to be true. It's different. It's that a always goes with the positive term. Let's see here, which term is positive? That's how you know. Okay, answer the following for horizontal or vertical hyperbolas. All right, let's see here. Let's see, the transverse axis connects the vertices, while the conjugate is perpendicular to the transverse. Midpoint of both is called the center, and the vertices are on the transverse axis. A from the center. So the length of A. Foci are also along the transverse axis, further apart than the vertices. And the focal radius is the distance from the center to the focus. And this is very different. C squared in this case is a squared plus b squared. I often remember that in the hyperbola, the general equation has a minus, so then the c squared has a plus, versus flipping that in an ellipse. All right, I'm not going to do this one for you, slide 10, but I am going to talk a little bit about the other one where I have this shifted, because I think that where the center is the origin is a little bit easier, and I want to try and make this video not so long. In fact, you know what? I'm just going to record a second video.